Hello friends, now we will start the next exercise, that is a 3.2. I will explain all the short example, theoretical part and all examples from the exercise 3.2. Now let us start. Now let's learn. Solution of triangle. Polar coordinates. Let O be a fixed point in a plane and let OX be a fixed ray in a plane. O is called the pole and the OX is called the polar axis. This is the polar axis. O is a fixed point in a plane. Next, let P be a point in a plane other than pole O. This is the point P whose coordinate is here. Okay. P be a point in a plane other than pole O, whose coordinate is r theta. Let OP is equals to r. This distance OP is equals to r. Measure of angle XOP is equals to theta. The order pair r theta determines the position of P in the plane. If you know r and theta, you can find out the position of particle, position of the point in a plane. Okay, they are called the polar coordinate of the point P. R is called the radius vector and theta is called vectorial angle of point P. Now remark here, the vectorial angle theta is the smallest non-negative angle made by OP with the ray OX. The value of theta lies between 0 to 2 pi. Third, pole has no polar coordinate. Here O has no polar coordinates. Now the relation between the Cartesian and the polar coordinate. Let O be the pole and OX be the polar axis of polar coordinate system. Here we take line OX as the x-axis and line perpendicular to x through O as a y-axis. Let P be any point in a plane other than O. Let xy and r theta be the Cartesian and the polar coordinate of P. To find the relation between them by the definition of trigonometric function, we know that sine theta is equals to y upon r and cos theta is equals to x upon r. From this figure, sine theta is y upon r and cos theta is x upon r from this right angle triangle OPM. Okay, therefore x is equals to r cos theta and y is equals to r sin theta. This is the relation between Cartesian and polar coordinate. Find the Cartesian coordinate of the point whose polar coordinates are 2 pi by 4. R is equals to 2, theta is pi by 4. We know that is using x is equals to r cos theta, y is equals to r sin theta, and we get here x is equals to, the value of r is 2. X is equals to 2 cos of pi by 4 and that's equals to 2 into cos of pi by 4 is 1 by root 2. 2 upon root 2 is root 2 and y is equals to r sin of pi by 4. Sin pi by 4 is 1 by root 2. 2 upon again root 2, that is root 2. The required Cartesian coordinates are root 2 and root 2. Next, find the polar coordinates of point whose Cartesian coordinates are 1 upon root 2 minus 1 by root 2. From the coordinates of the point whose coordinate of the point, we observe that this point lies in the fourth quadrant. R square is equals to x square plus y square. Therefore, r square is equals to 1 by root 2 bracket square plus minus 1 by root 2 bracket square. 1 by root 2 square is 1 upon 2 minus 1 by root 2 square is again 1 by 2. 1 by 2 plus 1 by 2, that is a 2 by 2 and that's equals to r square is 1. Therefore, r is equals to 1. Now next, x is equals to r cos theta, y is equals to r sin theta. And if we substitute here 1 by x, the value of x is 1 by root 2. 1 by root 2, r is 1 into cos theta minus 1 by root 2 into is equals to 1 into sin theta. And therefore here you will have cos theta is equals to 1 by root 2 and sin theta is equals to minus 1 by root 2. Now see this here, that is the value of tan theta is equals to minus 1. And then here how to find that angle, that is 1 means what, tan of pi by 4, and by allied angle, that is tan of 2 pi minus pi by 4. It lies in the fourth quadrant. Okay, that is the point is in the fourth quadrant. Here is a point. Okay, and therefore that is nothing but the tan of 7 pi by 4, and hence the required polar coordinates are 1 and 7 pi by 4. Solving a triangle. Three sides and the three angles of a triangle are called the elements of the triangle. If we have the certain set of three elements of a triangle in which at least one element is a side, एक मात्र त्यामध्ये side असलीच पाहिजे, then we can determine other three elements of the triangle. To solve a triangle means to find unknown element of the triangle. Using three angles of a triangle, we can't solve it. At least one side should be known. In triangle ABC, we use the notation length BC is equals to BC is equals to A, length CA is equals to AC is equals to B, length AB is equals to AB is equals to C. Means what? That is a side opposite to angle A is a small a, side opposite to angle B is a small b, and side opposite to angle C is a small c. That you have learned in the 9th standard. This notation is called as the usual notation. Following are some standard relation between elements of a triangle. The first is sine rule. In triangle ABC, A upon sine A is equals to B upon sine B is equals to C upon sine C is equals to 2R, where R is the circumradius of triangle ABC. Now see this here. Let AD be the perpendicular to BC. Okay, and therefore from this triangle, that is a triangle ADC, what is the sine C? Opposite side upon hypotenuse, that is AD upon AC. Therefore AD is equals to AC into sine C. Then therefore also that is from this triangle AD is equals to, but what is the value of AC? AC is the B. Therefore AD is equals to B sine C. Here is the AD is equals to B sine C. This is the height of the triangle. Now what is the area of the triangle? Area of triangle ABC is equals to 1 upon 2 BC into AD. BC is the base and AD is the height. Therefore 1 upon 2 BC, that is A into AD, means what? B sine C. Therefore this divided by 2 will come to the left hand side, and it will become 2 times area of triangle ABC is equals to AB sine C, and therefore 2 times area of triangle ABC is equals to AC sine B. 2 times area of the triangle ABC is equals to BC sine A, and in this way all these are equal. That is a 2 times area of the triangle ABC, 2 times area of triangle ABC, all are equal. Therefore AB sine C is equals to AC sine B is equals to BC sine A, and dividing this equality by ABC, and then you will get BC sine A upon ABC, AC sine B upon ABC, AB sine C upon ABC. Here BC get cancelled, and you will get sine of A upon A, sine of B upon B, sine of C upon C, and if you take its a reciprocal, then you will get A upon sine A is equals to B upon sine B is equals to C upon sine C, and this is the first one. Next, to prove that each ratio is equals to R. It's very interesting, as the sum of three angles is 180. At least one of the angle of the triangle is not right angle. Suppose that A is not a right angle. Now see this figure. A is not the right angle. Draw the diameter through A. Draw the diameter through the A. Okay. Let it meet the circle in the point P. Then AP is equals to 2R. Yes, it is a diameter and its length is twice the radius. And triangle ACP, consider the triangle CP is a right angle triangle. Angle ABC, angle ABC and angle APC, they are inscribed in this arc. They are inscribed in this same arc, and therefore measure of angle ABC, this is the measure of angle ABC, is equals to measure of angle APC. Okay, and here we have the sine B is equals to then sine P, as these two angles are equal. Sine B is equals to sine P. But what is a sine P? Opposite side upon hypotenuse. Opposite side is a AC. Okay, AC is a B. B upon 2R. B upon AP, and AP is a 2R. Therefore, sine of B, directly sine of B is equals to B upon 2R. Very interesting. Sine P is equals to sine B. It's a B upon AP. Okay, and therefore sine B is equals to B upon 2R. Therefore, sine B is equals to B upon 2R. That is a B upon sine B is equals to 2R. Means that is a from this ratio, from this here, we have that is a B upon sine B is equals to 2R. The value of this ratio is a 2R. Therefore, from 1 and 2, we have the value of each ratio, that is A upon sine A is equals to B upon sine B is equals to C upon sine C, and that is equals to 2R. Different forms of the sine rule. Following are the different forms of the sine rule in triangle ABC. First, A upon sine A, B upon sine B, A upon sine A is equals to B upon sine B is equals to C upon sine C is equals to 2R. Next is again A upon sine A is equals to 2R, therefore A is equals to 2R sine A. B upon sine B is equals to, therefore B is equals to 2R sine B. C upon sine C is equals to 2R, means C is equals to 2R sine C. And next we can write it also. Sine of A upon small a, sine of B upon small b, sine of C upon small c, that is also equals to K. Therefore, if you make the cross multiplication here, then you will get that the B sine A is equals to A sine B. Again the cross multiplication, C sine B is equals to B sine C. And from first and third, that is a C sine A, C into sine A is equals to A into sine C. We have this. Also, if you take the ratio of these, that is A upon B, here is A upon B is equals to sine A upon sine B. B upon C is equals to sine B upon sine C. We can get from here. Therefore, now see this here. Example. In triangle ABC, if angle A is 30 degree, angle B is a 60 degree, then find the ratios of the sides. Okay. To find the A as to B as to C, A is equals to 30 degree, B is equals to 60 degree. As A, B, C are the angles of the triangle, then what is happening? That is A plus B plus C is equals to 180. That is the sum of the measures of triangles is equals to 180. And that's why A is a 30, B is a 60, then you will get C is equals to definitely 90 degree. By the sine rule, you have A upon sine A is equals to B upon sine B is equals to C upon sine C. And if you substitute, it's a value. That is A upon sine 30 is 1 upon 2, B upon sine 60 is root 3 by 2, C upon 1. Therefore, you have that is the A as to B as to C. The ratios are 1 by 2 as to root 3 by 2 as to 1. Then multiplied these ratios by 2. And then you will get 2 into 1 upon 2, 2 get cancelled. 2 into root 3 by 2, 2 get cancelled. 2 into 1, then you will get 2 here. Therefore, A as to B as to C is equals to 1 as to root 3 as to 2. And next is example number 2. In triangle ABC, if A is equals to 2, B is equals to 3 and sine of A is equals to 2 upon 3, then find B. Now here the solution. By the sine rule, we have A upon sine A is equals to B upon sine B. And here, if we substitute the value, then you will get 2 upon, what is the value of sine of A? Is a 2 by 3. 3 upon sine B. If we make this simplification, that is a sine B is equals to. Then here is a 3 by 2 into 2 by 3, and that's equals to 1. Make the cross multiplication. Sine B is equals to 1, and then you will have B is equals to 90 degree. That is a pi by 2. Next is in triangle ABC. Prove that A in bracket sine B minus sine C plus b in bracket sin c minus sin a plus c in bracket sin a minus sin b, and that's equals to 0. Now consider the LHS. Now if we multiply the a with this bracket, b with this bracket, and c with this bracket, then you will get a sin b, next is a minus a sin c, b sin c, next is a minus b sin a, next c sin a, next is a minus c sin b. And if we collect the terms like this, that is a sin b minus b sin a, and b sin c minus c sin b, and c sin a minus a sin b, and that's the value of the first bracket. Second bracket is 0. For example, a upon sin a is equals to b upon, if you make the cross multiplication, then what you will get, a sin b minus b sin a, that's equals to 0, and hence LHS is equals to RHS, and hence the result, that is a in bracket sin b minus sin c bracket completable plus b in bracket sin c minus sin a plus c in bracket sin a minus sin b, and that's equals to 0. Now the next example number 4. In triangle ABC, prove that a minus b into sin c plus b minus c into sin a plus c minus a into sin b, and that's equals to 0. Now LHS, a minus b into sin c plus b minus c into sin a plus c minus a into sin b, and if we simplify this, that is a sin c minus b sin c, next is a b sin a minus c sin a, next is a c sin b minus a sin b, and if we again collect the term a sin c minus c sin a plus b sin a minus a sin b plus c sin b minus b sin c, and the value of each bracket is 0, and hence 0 plus 0 plus 0, that is equals to 0, and that is nothing but the RHS, and hence LHS is equals to RHS, and hence the result, in bracket a minus b into sin c plus b minus c into sin a plus c minus a into sin b is equals to 0. Now the cosine rule. In triangle ABC, just sine rule, similarly here the cosine rule. What is that here? The cosine rule in triangle ABC, a square is equals to b square plus c square minus 2bc cos a. Second is b square is equals to c square plus a square minus 2ca cos b. Third is a c square is equals to a square plus b square minus 2ab cos c. Take a as the origin x-axis along the AB and the line perpendicular to AB through A as a y-axis. The coordinates of ABC are, see this here, A, B, C. A as the origin. If we draw the perpendicular from C on the x-axis, then you will have, that is this distance is y and this distance is x. Therefore, cos of A is equals to x upon b. Sin of A is equals to y upon b. Therefore, x is equals to b cos A, y is equals to b sin A. Okay. And here, to prove that a square is equals to b square plus c square minus 2bc cos A. Now see this here, LHS. If first, LHS, that is a square. A square is equals to bc square. This is the bc square. The coordinate of bc are c comma 0 and the coordinate of a are b cos A and b sin A. By using the distance formula, you will have c minus b cos A plus 0 minus b sin A, and it's a bracket square. Expand this, that is a c square plus b square cos square A minus 2 bc cos of A, and last is a minus b sin A bracket square. It means that b square sin square A. Now collect the terms, that is a b square cos square A plus b square sin square A. If you take b square as a common, then in bracket you will get cos square A plus sin square A, and that is 1. And overall you will get here b square, c square plus b square and minus 2bc cos A, and that is the RHS. Okay. Now next, therefore a square is equals to b square plus c square minus 2bc cos A. Again, this cosine rule can be written as in this manner. That is a minus 2bc, bring this term to the left hand side and this a square to the right hand side. Therefore, 2bc cos A is equals to b square plus c square minus a square. And hence you will have, that is the cos of A is equals to b square plus c square minus a square upon 2bc. And similarly, we can prove that. What is the, we can prove that, that is the b square is equals to c square plus a square minus 2ca cos of b. c square is equals to a square plus b square minus 2ab cos c. Now what is the remark? The cosine rule can be stated in this manner. That is, in triangle ABC, cos of A is equals to b square plus c square minus a square upon 2bc. Cos of B is equals to c square plus a square minus b square upon 2ca. Cos of C is equals to a square plus b square minus c square upon 2ab. Now the example. In triangle ABC, if A is equals to 2, B is equals to 3, C is equals to 4, then prove that the triangle is obtuse angle triangle. We know that the angle opposite to largest side of a triangle is the largest angle of the triangle. Here the side AB is the largest side. C is the largest angle of the triangle ABC. To show that C is obtuse angle, therefore cos C is equals to a square plus b square minus c square upon 2ab, and therefore the value of A is a 2 square, B is a 3 square minus 4 square upon 2 AB, that is 3 into 4. And if you simplify this, then you will get that is a 4 plus 9 minus 16, and hence you will get minus 3 upon 24, and that's equals to minus 1 upon 8. As the cos of C is a negative, it means that C is a negative, C is a obtuse angle. When C is a negative, C is negative in the second and the third quadrant, and it's a positive in first and fourth quadrant. Therefore angle C is the obtuse angle, and hence the triangle ABC is the obtuse angle triangle. Next, example number 6. In triangle ABC, angle A is a 60 degree, B is a 3, C is 8. Then find A. Also find the circumradius of the triangle. By the cosine rule, we know that a square is equals to b square plus c square minus 2bc cos a. Substitute the value of b and c and a. Then you will get a square is equals to 3 square plus 8 square minus 2. 3 into 8 and cos of 60. 3 square means what? 9. 8 square means 64. And the product of these, that is a 2 into 3 into 8, that is a 48. Cos 60 is 1 upon 2. And if you simplify it, then you will get here 73 minus 24, and that is equals to 49. Therefore a square is equals to 49 and a is equals to 7. Now by the sine rule, you will have that is a upon sine a is equals to 2r, and hence you will have that is a is a 7. 7 upon sine 60 is equals to 2r. Therefore 7 upon the value of sine 60 is a root 3 upon 2, and if you simplify it, then you will get r is equals to 7 upon root 3, that is a multiplied and divide root 3, then you will get here that is a 7 root 3 into root 3, you will get here 3, and therefore the circumradius of the triangle ABC is 7 root 3 upon 3. Next problem, in triangle ABC, prove that A in bracket B cos C minus C cos B is equals to B square minus C square. Now consider the LHS. Here A in bracket B cos C minus C cos B. If you make the product, then you will get AB cos C minus AC cos B. And again this can be written as multiplied this equation by numerator and denominator by 2. Therefore here 1 upon 2 and 2 in bracket AB cos C minus 2AC cos of B. But what is the value of 2 times AB cos C? That is nothing but the a square plus b square minus c square with the help of the cosine rule. And next is a 2ac cos of b. Again its a value is a c square plus a square minus b square. And if you simplify this, then you will get 1 upon 2 a square plus b square minus c square minus c square minus a square plus b square. And here the plus a square minus a square get cancelled. Plus b square 2b square minus c square minus c square minus 2c square. Take 2 as a common, then you will get b square minus c square, and that's nothing but the RHS. And hence you will have a in bracket b cos c minus c cos b is equals to b square minus c square. Now the projection rule. In triangle ABC, a is equals to b cos c plus c cos b, b is equals to c cos a plus a cos c, and C is equals to A cos B plus B cos of A. And here we give the proof of one of these three statements by considering the all possible cases. Now the projection rules. In triangle ABC, first A is equals to B cos C plus C cos B. B is equals to C cos A plus A cos C. C is equals to A cos B plus B cos A. Here we give proof of one of these three statements by considering all possible cases. To prove that A is equals to B cos C plus C cos B, let altitude drawn from A meets BC in D. This is BC in D. Okay. BD is called the projection of AB on BC. BD is called the projection of AB on BC. And DC is called the projection of AC on BC. The projection of AB on BC is equals to C cos B. Okay. And the projection of AC on BC is equals to DC B cos C. Now we consider the cases. First case, B and C are the acute angle. Projection of AB on BC is equals to AB on BC is equals to BD C cos B, and the projection of AC on BC is equals to DC is equals to B cos C. Now from figure, see this here, A is equals to BD, A is equals to BC. That is nothing but the BD plus DC. And here the BD means what? C cos B, and DC means what? B cos C. And therefore here you will have A is equals to B cos C plus C cos B. Next we consider the angle B is a obtuse angle. Therefore B is a obtuse angle. Again the projection on BC, projection AB on BC, that is equals to BD. Okay, and this BD is equals to C cos of pi minus B, and this angle is a pi minus B. Cos of pi minus B is nothing but minus C cos B. Okay, and therefore, and the projection of AC, again the projection of AC on BC, AC on BC is equals to DC B cos C. This is the DC is equals to B cos C. This is the angle. Okay. Now from figure A is equals to, that is a BC, and this BC is nothing but that is a DC minus BD, but the DC is equals to B cos C, DC is equals to B cos C, and BD is equals to minus C cos B, and that minus and minus will become plus, and here that is a B cos C plus C cos B, and hence A is equals to B cos C plus C cos B, when that angle B is a obtuse angle. Now third case, that is the angle B is a right angle. In this case the D coincides with B, and from the RHS, that is a B cos C is equals to C cos B. Okay, and the measure of angle, that B is a 19, cos of 90 is 0. Okay, and therefore we have here that is equals to BC, and hence BC is nothing but the A, and hence that is A is equals to B cos C plus C cos B. Similarly, we can prove the cases where C is a obtuse angle and C is a right angle. Therefore, in all possible cases, A is equals to B cos C plus C cos B, and similarly we can prove the other statement. Now next, in triangle ABC, prove that A plus B into cos C plus B plus C into cos A plus C plus A into cos B, and that's nothing but A, B, C, A plus B plus C, sorry. Therefore, now consider the LHS. In bracket A plus B into cos C plus in bracket B plus C into cos A plus in bracket C plus A cos B. Okay, perform their multiplication and then you will get, that is A cos C plus B cos C, A cos of A plus C cos of A, C cos of B plus A cos of B. Collect the terms, that is A cos C plus C cos A, and that's nothing but the first bracket is nothing but B, second is C, and third is A, and hence we have, that is A plus B plus C, and that's equals to the RHS, and hence you remember all these cosine rule. Okay. Now next, in triangle ABC, prove that A cos C minus cos B, that is A in bracket cos C minus cos B, is equals to 2 in bracket B minus C cos square in bracket A by 2. Again by the projection rule, A cos C plus C cos A is equals to B. A cos B plus B cos A is equals to C. Okay. And therefore this can be written as A cos C is equals to B minus C cos A. A cos B is equals to C minus B cos A. Now consider the LHS. The LHS is A cos C, A in bracket cos C minus cos B. That is LHS is equals to A in bracket cos C minus cos B. We perform the multiplication, A cos C minus A cos B. And again the value of A cos C. The value of A cos C is equals to B minus C cos A. Okay. And the value of A cos B, again the value of A cos B is equals to C minus B cos A. We substitute the values, and after the simplification you will get here, that is a B minus C in first bracket, and from these two we will take the cos of A as a common. म्हणजे काय मिळेल ब्रॅकेट मध्ये B minus C cos of A. Again from these terms we will take the B minus C common घेणार. Then in bracket you will get 1 plus cos of A. But what is the 1 plus cos of A? That is the 2 cos square A by 2 by our trigonometry that you have learned in the 11th standard. Therefore B minus C into 2 cos square A upon 2. That is a 2 in bracket B minus C into cos square A by 2. And hence A cos C minus C cos A cos C, sorry, A in bracket cos C minus cos B is equals to 2 times in bracket B minus C into cos square in bracket A by 2. Now next, prove the, now here, prove the cosine rule using projection rule. Given in triangle ABC, A is equals to B cos C plus C cos B, B is equals to C cos A plus A cos C, C is equals to A cos B plus B cos A. Multiply these equations by A, B, C respectively. Then you will get, if you multiply here A, then you will get A square, AB cos C plus AC cos B. If you multiply B, B square, BC cos A plus AB cos C. If you multiply C, then you will get C square, AC cos B plus B square cos A. Okay, and hence you will get these equations. That is A square is equals to AC cos C plus AC cos B, B square is equals to BC cos A plus AB cos C, C square is equals to AC cos B plus BC cos A. Now A square plus B square minus C square is equals to, first of all we will write the value of A square, then B square and the minus C square. Now simplify this bracket. You will get AB cos C plus AC cos B plus BC cos A plus AB cos C minus AC cos B minus BC cos A, and these two terms will get cancelled. That is AC cos B, here AC cos B get cancelled. BC cos of A, here is a BC cos of A, these two terms get cancelled. And then what is overall? That is AB cos C and here is AB cos C. That is you will get 2 times AB cos C, and hence a square plus b square minus c square is equals to 2ab cos c, and hence c square is equals to a square plus b square minus 2ab cos c. Similarly, we can prove that is a square is equals to b square plus c square minus 2bc cos a. Next is a b square is equals to c square plus a square minus 2ca cos b. Now the application of sine rule, cosine rule and the projection rule. First is half angle formula. In triangle ABC, if a plus b plus c is equals to 2s, where s is the semi-perimeter. Therefore, sine of a by 2 is equals to in root of s minus b into s minus c upon bc. Now we know that from the trigonometry, 1 minus cos of a is equals to 2 sine square a by 2. Substitute the value of cos of a, which is b square plus c square minus a square upon 2bc, that is 1 minus in bracket b square plus c square minus a square upon 2bc, that is equals to 2 sine square a by 2. If we simplify, that is a 2bc into 1, that is a 2bc, open the bracket, minus b minus c, and this minus and minus will become plus. Okay, therefore this divided by 2bc, therefore that is equals to 2 sine square a by 2. And again if we simplify here, that is a square minus in bracket b square plus c square minus 2bc upon 2bc, that's equals to 2 sine square a by 2. But what is this? This is the perfect square. b minus c bracket square upon 2bc, and that is equals to 2 sine square a by 2. And then simplify this. And then in bracket you will get a minus in bracket b minus c in first bracket. Second bracket a plus b minus c, okay, upon 2bc, and that's equals to 2 sine square a by 2. Okay, here again the simplification, that is a minus b minus in bracket b minus c. We can write it like this, a plus b plus c minus 2bc. Okay, this minus and minus, that will become plus, that is a plus c. That we add here plus b and here minus 2b. Similarly here a plus b plus c, and that is a plus b plus c extra 1c minus with minus 2c here. Then you will get, that is a 2bc is equals to 2 sine square a by 2. म्हणजे इथे काय करणार आपण, यामध्ये एक प्लस बी इथे आपण ऍड करणार, म्हणजेच इथे मायनस 2b झाला, आणि इथे प्लस सी करणार, म्हणजे इथे मायनस 2c झाला. ओके, नाउ व्हाट इज द a plus b plus c? That is a semi perimeter. Means what? a plus b plus c, this divided by 2, and that is equals to s. Therefore a plus b plus c is equals to 2s. a plus b plus c is a 2s minus 2c, 2s minus 2b in second bracket 2s minus 2c upon 2bc is equals to 2 sine square a by 2. Take 2 as a common, 2 into 2 4 upon 2, okay, and these 2 on this side, that get cancelled, and therefore you will get in first bracket s minus b into s minus c upon bc is equals to sine square a by 2, and taking the square root on both sides, then you will get sine of a by 2 is equals to in root of in first bracket s minus b in second bracket s minus c upon bc. Next is a cos of a by 2 is equals to in root of s into s minus a upon bc. We have 1 plus cos of a is equals to 2 cos square a by 2. Substitute the value of cos of a, which is b square plus c square minus a square upon 2bc is equals to 2 cos square a by 2. And then simplify this, that is a 2bc plus b square plus c square minus a square upon 2bc is equals to 2 cos square a by 2. Again the simplification, that is a b square plus c square plus 2bc minus a square upon 2bc is equals to 2 cos square a by 2. Again this is nothing but the b plus c bracket square minus a square upon 2bc is equals to 2 cos square a by 2. Now here a square minus b square type. In the first we add it and then subtract it. Therefore here you will get b plus c plus a in first bracket, second bracket b plus c minus a, and again this divided by 2bc is equals to 2 cos square a by 2. Therefore here you will have b plus c plus a. Again add here plus a and minus a. If we add plus a then minus a, that will become minus 2a, and therefore here a plus b plus c, a plus b plus c here minus 2s is equals to upon 2bc is equals to 2 cos square a by 2. But what is the value of here a plus b plus c? That is a 2s. Here a plus b plus c is a 2s minus 2a. is equals upon 2bc is equals to 2 cos square a by 2. Take 2 common, 2 into 2, 4 upon 2 is equals to 2 cos square a by 2. 1, 2 will get cancelled on from the both sides, and 1, 2 from the numerator and the denominator, and hence you will get s into in bracket s minus a upon bc is equals to cos square a by 2, and hence cos of a by 2 is equals to in root of s into s minus a upon bc. Okay. Next is the tan of x by 2 is in root of s minus b into s minus a upon s into s minus a. Now take the ratio of tan of a by 2, which is sine of a by 2 upon cos of a by 2, that is in root of s minus b into s minus a upon bc, upon in root of s into s minus a upon bc. That just we have proved it, and after simplification then you will get this bc and bc get cancelled, and in root of s minus b, this is numerator and this is the denominator, numerator of the denominator, which is the s into s minus, and hence tan of a by 2 is equals to in root of in first bracket s minus b into s minus c upon s into in bracket s minus a. Similarly, we can prove that sine of b by 2 and the sine of c by 2, cos of b by 2 and the cos of c by 2, tan of b by 2 and the tan of c by 2. By the symmetric of the formulas you can remember this. Okay. Whenever there is a b by 2, then what should be a sine of s minus a, s minus upon ac. When there is a c by 2, then s minus b, s minus a divided by ab. Cos of b by 2 is nothing but here is in root of s in bracket s minus b upon ac. C by 2 is in root of s in bracket s minus c upon ab, and in this way you can remember all these formulas. Heron's formula. If ABC are the sides of triangle ABC and a plus b plus c, that is equals to 2s, then area of the triangle ABC, that's equals to in root of s into s minus a into s minus b into s minus c. We know that the area of the triangle ABC is equals to 1 upon 2 AB into sine c. Okay. Therefore, area of the triangle ABC is equal. Now here the area of the triangle ABC is equals to 1 upon 2 AB into 2 sine of c by 2 into cos of c by 2. Sine c means what? 2 times sine of c by 2 into cos of c by 2. And here 1 upon 2 AB into 2. The value of sine of c by 2 is in root of s minus b into s minus a upon ab into in root of cos of c by 2 is s into s minus c upon ab. And if we simplify it, then now these two to get cancelled here, you will get ab. Take all the terms in a single root, that is s minus b, s minus a, s minus c into s upon ab into ab, that is a square b square. And its a square root is ab, and then you will get here ab upon ab in root of s minus b into s minus a into s minus c. And hence area of the triangle ABC is equals to in root of s into s minus a into s minus b into s minus c. Now the next is a Napier's analogy. In triangle ABC, tan of b minus c upon 2 is equals to b minus c upon b plus c into cot of a by 2. By the sine rule, we know that b is equals to 2r sine b and the c is equals to 2r sine c. Then what is the ratio? That is b upon c is equals to 2r sine b upon 2r sine c. Okay, now here we will take the dividendo and the componendo. That is b minus c upon b plus c. Then you will get 2r sine b minus 2r sine c upon 2r sine b plus 2r sine c. Take 2r common and cancel it. And next apply the sine of b minus c. That is equals to 2 times b plus c upon 2 into sine of b minus c upon 2, and to the denominator 2 times sine of b plus c upon 2 cos of b minus c upon 2, and hence here you will get cos of b plus c upon 2 sine of b plus c upon 2, then you will get cot of b plus c upon 2. Next is a sine of b minus c upon 2 upon cos of b minus c upon 2, that is a tan of b minus c upon 2, and hence you will get here that is a b minus c upon b plus c is equals to cot of this b plus c is equals to pi minus a, that is a, we have a plus b plus c is equals to pi, and hence b plus c is equals to pi minus a divided by 2, that is a pi by 2 minus a by 2. That is the cot of pi by 2 minus a by 2 is nothing but the tan of a by 2 into tan of b minus c upon 2, and hence you have that is the tan of b minus c upon 2 is equals to, now this tan of a by 2 when it comes to this left hand side it will become cot of a by 2, and hence tan of b minus c upon 2 is equals to b minus c upon b plus c into cot of a by 2. And similarly, we can prove that tan of c minus a upon 2 is equals to c minus a upon c plus a into cot of b by 2. Tan of a minus b upon 2 is equals to, in bracket, a minus b upon a plus b into cot of c by 2. And now the solved examples. In triangle ABC, a is equals to 13, b is equals to 14, c is equals to 15. Then find the values of cos a. That is, we know that s is equals to a plus b plus c upon 2. Therefore, 13 plus 14 plus 15 upon 2, and that's equals to divided by 2 is equals to 21. Therefore, what is s minus a? 21 minus 13, that 8. S minus b, 21 minus 14, 7. S minus c, 21 minus 15, that is equals to 6. Now, cos of a is equals to b square plus c square minus a square upon 2bc. Substitute the values, that is 13 square plus 15 square minus 14 square upon 2 bc, 13 into 15, and after the calculation you will get that is the cos of a is equals to 33/65. Next is the sine of a by 2. Similarly, substitute the values. Sine of a by 2 is equals to in root of s minus b into s minus c upon bc, that is 7 into 6. We have calculated the values into bc, 14 into 15, and after the calculation you will get here that is a 7 1 and the 7 2. Now here there is, and you will get here, okay, that is in root of 1 upon 5, that is 1 by the root of 5. Cos of a by 2, that is the cos of a by 2 is equals to in root of s into s minus a upon bc. Substitute the values and simplify it, then you will get that is a 2 upon a root of 5. Next is the tan of a by 2. We know that sine of a by 2 upon cos of a by 2, that is 1 by root 5 upon 2 by root 5. Then you will get tan of a by 2 is equals to 1 upon 2. Next, area of the triangle. Area of the triangle ABC is in root of s into s minus a into s minus b into s minus c. That is, area of the triangle ABC is equals to in root of 21 into 8 into 7 into 6, and that's equals to 84 square unit. Next is a sine a. What is a sine a? That is, a sine a is equals to 2 sine of a by 2 into cos of a by 2. Now substitute the value of sine of a by 2 cos of a by 2. That is a 2 into 1 by root 5 into 2 upon root of 5. Then you will get 4 upon root 5 into root 5 is a 5. Next is in triangle ABC. Prove that cot of a by 2 plus cot of b by 2 plus cot of c by 2 is equals to a plus b plus c upon b plus c minus a into cot of a by 2. Therefore, LHS is cot of a by 2 plus cot of b by 2 plus cot of c by 2. They are reciprocal. That is 1 upon tan of a by 2 plus 1 upon tan of b by 2 plus 1 upon tan of c by 2. Now substitute the values. That is, you will get in root of s minus a upon s minus b into s minus c, and similarly the other values in root of s into s minus b upon s minus a into s minus c plus in root of s into s minus c upon s minus a into s minus b, and after simplification, that is what you are getting here, multiplied n and a for this root sign, that is s minus a. Then you will get in root of s into s minus a bracket square to the denominator s minus b into s minus c into s minus c. For this, multiplied n and d by s minus b. Then you will get s into s minus b bracket square upon s minus a into s minus c into s minus b. And for the third, multiplied n and d by s minus c. Therefore, you will get in root of s into s minus c bracket square upon s minus b into s minus a into s minus c. And next, that is here, take the common, which is a common, s in root of s minus b, s minus c, s minus a from all these three terms. And what's remaining? The root of s minus a. And this is a square sign. A square and that's a root. Get cancelled. You will get here root of s minus a bracket square plus root of s minus b bracket square plus root of s minus c bracket square. Square and root get cancelled and you get, that is a in root of s upon s minus b, s minus c, s minus a, s minus c. And what is overall? This is s plus s plus s. That is a 3s. And a plus b plus c, take minus n common. But what is the value of a plus b plus c? That is a 2s. Therefore 3s minus 2s. You will get single s. Okay. Now here, this s upon in root of s minus a. Okay. Then this is the, this can be again written as multiplied Now here we'll start the fourth question. In triangle ABC, prove that sine of b minus c upon 2 is equals to b minus c upon a into cos of a by 2. Again, by the sine rule, we know that a upon sine a is equals to b upon sine b is equals to c upon sine c is equals to k. Here a is equals to k sine a is equals to b k sine b is equals to c is equals to k sine c. Now consider here RHS. What is RHS? RHS is equals to b minus c upon a into cos of a by 2. And that's equals to k sine b minus k sine c upon k sine a. And into it's a cos of a by 2. Take the k as common and cancel from the numerator and the denominator. You will get sine b minus sine c upon sine a into cos of a by 2. Now here we will apply the formula for sine c minus sine d. And what is that formula? That is the 2 times, here is a sine, we can apply here, sine of c minus sine d formula. What is that formula? That is a 2 times cos of c plus d. Here is a c plus d upon 2 into sine of c minus d upon 2. Now here same formula here we have apply here. That is a 2 times cos of b plus c upon 2 into sine of b minus c upon 2 upon 2 sine a by 2 into cos of a by 2 into cos of a by 2. Now this a by 2, cos of a by 2 get cancelled, and you will get here again 2 get cancelled. Cos of b plus c upon 2 into sine of b minus c upon 2 upon sine of a by 2. Next, what is the value of b plus c? Now a plus b plus c is pi. Therefore, b plus c is equals to pi minus a divided by 2. That is the cos of pi by 2 minus a by 2 into sine of b minus c upon 2. Now sine of 90 minus theta is cos of 90 minus theta is sine theta, means what? Sine of a by 2 into sine of b minus c upon 2 upon sine of a by 2. And therefore here sine a by 2 get cancelled, and you will get here sine of b minus c upon 2, and that is equals to LHS. And hence b minus c upon a into cos of a by 2 is equals to sine of b minus c upon 2. It's proved. Next is with the usual notations, prove that 2 times a sine square c by 2 plus c sine square a by 2 is equals to a minus b plus c. Okay. Now consider the LHS. That is a 2 in bracket a sine square c by 2 plus c sine square a by 2 is equals to. Now here we have that is a multiplied by 2. Then you will have that is a 2 into sine square c by 2. Next is a 2 into sine square a by 2. But what is the value of 2 sine square c by 2? We know the formula, that is a 1 minus, here is a cos of a is equals to, that is 2 sine square a by 2. And by using this formula, we have here that is a 2 sine square c by 2 is nothing but 1 minus cos c. And 2 sine square a by 2 is 1 minus cos of a. And therefore next substitute the value of c, that is the cos of c. 1 minus a square plus b square minus c square upon 2ab plus c into cos of a, b square plus c square minus a square upon 2bc by using the cosine rule. And then this is a simplification, that is a in bracket 2ab minus a square minus b square and plus c square, if you open the bracket here, upon 2ab plus c, again 2bc minus b square minus c square plus a square upon 2bc. And the next is here, that is a get cancelled, cc get cancelled, you will get upon 2b, that is a 2ab minus a square minus b square plus c square upon 2b plus 2bc minus b square minus c square plus a square upon 2b. And if you simplify this, then you will get 2ab minus a square minus b square plus c square plus 2bc minus b square minus c square plus a square. And here that is a 2ab, okay, plus 2bc. Next, what's happening? Here is a plus a square minus a square get cancelled. Minus b square and minus b square minus 2b square plus c square minus c square get cancelled. Okay, and therefore overall you are getting 2ab minus 2b square plus 2bc upon 2b. And now here again take 2b as a common, then in bracket you will get a minus b plus c upon 2b, and hence here LHS is equals to 2b get cancelled. LHS is equals to a minus b plus c, and that is equals to RHS, and hence 2 in bracket a sine square c by 2 plus c sine square a by 2 is equals to a minus b plus c. Now the next problem, in triangle ABC, a cube sine of b minus c plus b cube sine of c minus a plus c cube sine of a minus b is equals to 0. Now the solution by the sine rule, a upon sine a is equals to b upon sine b is equals to c upon sine c is equals to k, and by the therefore here a upon sine a is equals to k, therefore a is equals to k sine a. Similarly b is equals to k sine b, c is equals to k sine c. Now consider the LHS. LHS is equals to a cube sine of b minus c plus b cube sine of c minus a plus c cube sine of a minus b. Now the expansion of sine of b minus c, sine b cos c minus cos b sine c plus b cube sine of c minus a, sine c cos a minus cos c sine a. And the next is a c cube sine of a minus b, sine a cos b minus cos a sine b. Now again here we will substitute the values. The first is here a cube, and next is a substitute the value of sine b here and the cos of sine c here by using the sine rule. Again the sine of c and the sine of a, keep the cos as it is, plus again here the value of sine a and the sine b. Then here you will get a cube in bracket b upon k cos c minus c upon k cos b, bracket complete, plus b cube in bracket c upon k cos a minus a upon k cos c, bracket complete, plus c cube in bracket a upon k cos b minus b upon k cos a, and hence it. And again if we simplify it, then you will get, that is a take 1 upon k common from all the terms, then you will get 1 upon k in bracket a cube b cos c minus a cube c cos b plus b cube c cos a minus b cube a cos c plus c cube a cos. Okay. The last is here. I think that here must be the b cos of b minus c cube b cos of a, and again if we simplify here, substitute the value of cos c, that is here a cube b cos c, the value of cos c, a cube plus b cube minus c upon 2ab. Again the substitute the value of cos of b, that is a cube c, a c square plus a square minus b square upon 2ca. Okay, plus next is a plus b cube c, again the value of here the value of cos of a, that is a b square plus c square minus a square upon 2bc, and next is a minus ab cube and the value of cos c, a square plus b square minus c square upon 2ab, plus next is a ac cube and again the value of cos of b, that is a c square plus a square minus b square upon 2ca, and the last is a value of cos of a, that is again minus bc cube b square plus c square minus a square upon 2bc, and by using the cosine rule. And if we simplify it, that is in first case, see this here a cube b and here is the 2ab, that ab get cancelled for the denominator. For similarly for all the terms you can get here, that is a first is you will get 1 upon 2k a square in bracket b square plus c square minus b, a square plus b square minus c square. For the second again ca, here ac get cancelled, you will get one more a square, therefore a square in bracket a square plus c square minus b square, plus similarly for here, that is a bc get cancelled, you will get b square in bracket b square plus c square minus a